Welcome to class of physics. In previous videos, we studied about the pin configuration of IC 7400 and IC 55 timer. In this class, we are going to study about the functional block diagram of IC 555 timers. This IC 555 timers includes different components. So one is resistor components as a voltage divider, and next one is comparators, flip-flops, and one more is transistor. These are the different components that which is configure it in itself in a IC355 timers. Now let's see what are the working of these components: voltage divider, comparators, flip-flop, and transistors. Okay. And this is also same the block diagram, functional block diagram of IC355 timer that is given in textbooks. Comparators, resistors, flip-flops, and transistors. Let's see one by one what are these components and how this works. Comparator is a device that compares two voltages or currents and outputs are digital signals indicating which is larger. The working of comparator is explained in this diagram. An E555 timer. The comparators are used as upper comparators UC and lower comparator LC. These comparators requires a reference voltage to give any digital outputs. The thing is here, the comparator is simply, it is a device that used to compare the two inputs and give the output. That output is indicates which input is larger. Okay, then that output is in terms of digital signals. Digital signals here are using two signals, one is high and low, that is 0 and 1. Okay, here this we call it as non-inverting terminal, or this is positive terminal where we are applying positive signals, and that one is inverting terminal, so that is negative terminal, and we are getting the output here. Okay, so the output may be 1 or 0. When it is 1 and when it is 0, let's see. When the input voltage at the inverting terminal or negative terminal is, I will simply write negative terminal and this is positive terminal. When the positive terminal voltage is greater than negative terminal voltage, then the output will be 1. That means this will be larger than negative terminal, then output is 1. In another case, when the positive terminal voltage is less than negative terminal voltage, then it will give 0. That indicates here the outputs 1 and 0 indicates the 1 indicates the positive terminal voltage is larger than negative terminal voltage. That output is 0. That indicates the negative terminal voltage is greater than positive terminal voltage. So like that, this comparator compares the input voltages and give the output as which is larger and which is smaller. Okay. In IC355 timer, there are two comparators. One is upper comparator and the other one is lower comparators. And next one is resistors. Yes. The three resistors 5K, 5K, 5K are used to create a resistive voltage dividing networks. These three resistors are used to divide the voltages. Okay. Those three resistors of 5 kilo ohm resistors each. Maybe this is the reason this IC could call it as IC355 timers. Such that in the above diagram, voltage at a point A is 1 by 3 VCC and voltage at point is 2 by 3 VCC, which are used for comparison. Okay. In above diagram means in this diagram. Here 2 points, one is A and the other one is B. At this point, the voltage is divided by 1 by 3. 1/3 of the applied voltage. Here we are going to apply the voltage VCC. So here 1/3 of VCC is available, and at this terminal 2/3 of VCC is available. Suppose here we are applying 15 volts, then 1/3 of VCC means it is about 15 by 3, 5 volt, and here it is 2 by 3. It means it is about 10 volts. 5 volt is available, 10 volt is available. These voltages are supplied to the comparators for the comparison of these pins, these two another pins. So that here we are using IC355 3 resistors as voltage divider. Next one is flip-flop. The flip-flop used is SR flip-flop, which works as follows. SR flip-flop means set and reset flip-flop here. When S is 1, Q is 1, thus the flip-flop is set. When R is 1, Q is 0, thus the flip-flop is reset. Okay. The output of lower comparator connected to the set pin and set pin of the SR flip-flop, and output of upper comparator is connected to a reset pin R of the SR flip-flop. Okay. So here same, the truth table is there. The truth table is similar to the logic gate truth table, but here the outputs are different. Now consider that case. So this represents a flip-flop. One is input as set, and the input is R, that is reset. They are getting two outputs. That output is Q. So here there is a complement of the Q bar output. Now when it is 0, when it is 1. The first case is set case. S is 1, R is 0. If S is 1, R is 0, then Q is 1. Now the Q is 1. Q bar is its complement, it is 0. This is the one case. In another case, okay, now the state is changes. This is S is 1, R is 0, then Q is 1 and Q bar is 0. This case is completes. Now what happens? The S state is changes to 0. S is 0, R is remains same, 0. Then output also remains same. There is no change in the output until the reset is set. Reset is changes. Now the Q bar is 0. This is the second condition. S is 0, R is 0 after the set conditions. So then Q is remains same as 1 only. Then Q bar is 0. In next condition we are changing R, reset. Reset is 1. S is same as previous, it is 0. Now reset is R is 1, S is 0. That is the second here. R is 1, then Q is 0. Q will be 0. Q bar is 1. So this is the next case. After that, again R, after reset, R is 0. R becomes 0. S is same, 0 only. R changes from 1 to 0. Then the output again remains same. So that is 0 only. The Q bar is 1 only. Okay. Now both are changes at a time. Both are becomes 1 and 1. This is invalid case actually. So that is given as 0. This is the output of flip-flop. Simple. If S is 1, then Q is 1. Then Q bar is 0. If R is 1, then Q is 0. Q bar is 1. So this is the condition of flip-flop. Okay. This flip-flop is major role in the 555 timer because this is only change the states. Next one is transistor. The transistor is NPN bipolar junction transistor, which is used as discharge transistor. Here we are using this transistor. Here it is. This transistor is used for discharging. So how it discharges? Through the ground. See here, this is connected to the Q bar complement output. Suppose here the output is 0, Q bar output is 0, then it does not conduct because this is connected to the base of the transistor. So when it is 0, then it does not conduct because there is insufficient voltage for this working of the transistor. That means we should apply the base voltage greater than 0.7 volt. When Q bar is 1, it starts conducting. It starts conducting through the ground and discharge through the ground, and that terminal discharge terminal connected to the terminal 7 of the, here it is. For this terminal we are connecting the transistor. Through this it is going to discharge. Okay, so for discharging purpose we are configure this transistor in IC 555 timer. So these are the components present in the 555 timers and their workings. Now let's see how the 555 timer works wholly. Working of 555 timers. Okay. Yes. 555 timer block diagrams. The voltage divider consists of 3 identical 5K resistors that creates 2 reference voltages at 1/3 and 2/3 of the supplied voltage, which can vary from 5 to 15 volt. The timer voltage divides the 5 below where 2 comparators. Okay, that means the voltage divider is connected to 2 comparators. Comparator is a circuit element that compares two analog input voltages, its positive non-inverting and negative reverse input terminals. If the input voltage at the positive terminal is higher than the input voltage at the negative terminal, the comparator will emit 1, vice versa. If the voltage at the negative terminal input terminal is higher than the voltage at the positive terminal, then the comparator will generate 0. Okay, so instead of reading this, I am going to explain this whole steps by using the block diagram. Now take the screenshot for your reference purpose, for note purpose. Then I will go to the working of this 5 timer. Yes. Simple. There is a voltage divider network. This voltage divider network is connected to plus VCC. To this voltage divider network we are going to connect 2 comparators. The output of 2 comparators are connected to the flip-flop. The output of the flip-flop is connected to the output device, and through that again we are connecting that same terminal to the transistors. Yes. How the output generates, let's see. Purpose of this 355 resistors is as a voltage divider. At this point the voltage is 1/3, at this point the voltage is 2/3. These 2 comparators will emit the outputs. So that is, if positive terminal voltage is greater than if positive terminal voltage is greater than negative terminal voltage, it will emit 1. If positive terminal voltage is less than negative terminal voltage, it will emit 0. Okay, now consider the case. Here the positive terminal voltage is greater than negative terminal voltage, then it is 1. That means it will compare the 2 voltages. One is this supplied voltage to this voltage divider as 1/3 volt, and another one is the trigger voltage. Here whatever triggering pulse applied, triggering voltage applied, so that will compare with these two. If the triggering voltage is less than the positive terminal, that is 1/3, then it will emit 1. So it is 1/3. And again the positive terminal of the comparator is at the threshold, the same. These two are connected in the next unstable multivibrators. In that case we will stay briefly. In these conditions, here it is less than 2/3, so that it is 0. In these conditions R is 1 and this is R is 0, S is 1. Then what will be the Q? Q is 1. If Q is 1, it is Q bar is 0. If Q bar is 0, then the output is 1. So like that this IC 355 timer works. The output of simple voltage divider is work as voltage dividing. That voltage dividing providing 2 voltages, that comparing voltages. One is at point A is 1/3, at point B is 2/3 voltages, and these two are connected to the 2 comparators. So if you take this as upper comparator and is lower comparators, the 1/3 voltage is supplied to the positive terminal or non-inverting terminal of the lower comparators, and 2/3 of the voltage is connected to inverting terminal of the upper comparators. The output of upper comparator is connected to the reset pin, and the output of lower comparator is connected to the set pin. Then flip-flop will give the output depending on the input values. If S is 1, R is 0, then it will give output at Q is 1. Okay, if R is 1, Q is 0, then it will give output 0, and QR will complement the Q. Okay, if it is 0, then the QR is 1. If Q is 1, QR is 0. Again we are getting the output is the complement of Q bar. Here we are getting the output. So this is the working of IC 555 timers, but we cannot use this single chip as a multi vibrators, but we have to connect external components like resistor and capacitor, because here the capacitor of larger value we cannot create in a transistors, so that externally we have to use the capacitor and resistors. For this is enough. Next class we are going to study about Thank you.